All right. Okay, so I'm going to be taking a look at the final exam from fall 2018, and this is question 7, which is on the volume of revolution. Okay, so let's write down what our parameters are that they give us in the problem. So the first one is we're looking at the equation y equals minus x squared plus 3x plus 4. Okay, and then we've got it's bounded also by y equals minus x plus 4. So I've got these two equations here, right? And then we want to set it about, we want to go about the line y equals minus 1. Y equals minus 1 is the horizontal axis. And then part B says the line x equals positive 6, which is a vertical axis. So we're going to do a disk method in part A and then a shell method in part B. Okay, but first let's set up a graph. So we need to figure out where these two intersect each other. Okay, and then we want to be able to take a look at that. So let's do points of intersection. Okay, so the first thing I'll do is I'll set these two equal to each other. Minus x squared plus 3x plus 4 equals minus x plus 4. Okay, so now we're going to combine like terms. I'm going to add the x to both sides. I think the 4's are going to cancel out. So I'm going to get minus x squared plus 4x equals 0. So I factor out an x, right? So what do I get? I get basically minus x plus 4. Set it equal to 0. I'm looking at x is equal to 0. And then x is equal to positive 4, right? I set each of these equal to 0, and I solve. It gives me my points of intersection. We'll also see that on the graph, too. So we know we're going to go about the line y equals minus 1, and I'm going to go about the line x equals positive 6. So I'm going to kind of focus my graph this way. So 1, 2, 3, 4. 6. Here's line x equals 6. This is what we're going to rotate around later. Okay, and then I'm going to go 1, 2, 3, 4, x equals positive 4. Okay, so my line y equals minus x plus 4 is going to look like this. Okay, and then I have the parabola. This here, and then it ends up there, and then it looks like I'm going here to. And here's my parabola. I'm sketching these out a little bit loosely. This is just for me to visualize. It really helps, I find, to visualize. And let me write out, here's my dashed line. This is y equals minus 1. So the first thing, part A, the first graph is they want us to do y equals minus 1. The volume of revolution means we're going to go around this right here. Okay, so before, on some of the other examples we did, we were going around the x-axis. This is our x-axis. Going around the x-axis, okay, but now we need to be able to calculate out our radius. If you can imagine, I've got another shape that's kind of coming down like this with a bump on top of it. So I've got a graph that's doing this, right, as I go around here. Okay, and I'm going to basically go from 0 to 4 as my bound of integration. We'll talk about what it's going to look like when we go around the vertical axis in a minute. Okay, so now when I go around a horizontal axis, I'm taking a look at the disk or washer method. Okay, remember this is a pi r squared. Okay, so I go, this is a dx. Okay, so now I need to think about my outer and my inner radius. Okay, so now my outer radius is going to be the difference between this function here, my upper, because this forms the outer edge of the circle as we're going around. My upper function, right, which is minus x squared plus 3x plus 4, and my axis of rotation, which is equal to minus 1. Okay, so I have to take the difference between here and here, not here and here. If I go around the x-axis, my y is equal to 0, so we don't even see this subtraction. But as I go around y equals minus 1, I'm taking into account what that radius is, the difference between this spot and this spot, this spot and this spot right there, okay? Which is going to look like minus x squared plus 3x. This is a plus 1, so plus 5. It gives me my outer radius. I'll put parentheses around that. Okay. My inner radius is the same type of a calculation, right? Except that I've got minus x plus 4 minus 1. So this ends up looking like minus x plus 5 as my inner radius. Okay, so when I go to integrate this, right, my intersection points from 0 to 4 form my bounds of integration. So I'm going to go from 0 to 4, pi r outer squared minus from 0 to 4, pi r inner squared. Okay. This is pi r squared minus pi r squared, the outer minus the inner. Okay, and that carves out this spot right there. Okay, so let's fill this out. So from 0 to 4, pi, our outer, we said was minus x squared plus 3x plus 5 squared. And that's a dx minus, I'm going to go from 0 to 4, same bounds of integration, pi, our inner minus x plus 5 squared dx. Now you may see some solution sets, okay, where they're talking about we factored out the pi's, okay. So I could also write this as pi from 0 to 4. I'm going to go r outer squared minus r inner squared dx, which looks like pi 0 to 4 minus x squared plus 3x plus 5 quantity squared minus x plus 5 quantity squared, and that whole thing times dx. Both of these are completely correct, and you can leave them. Okay, they're just asking us, I'll put a little mini box around that one and a mini box around this one. They didn't ask us to evaluate it, they just asked us to come up with the bounds of integration, set up the integral for it. Okay, so we're looking for, do you have the points of intersection? Do you have r squared outer minus r squared inner? Okay, pi is times that for each one. Okay, part B says we're going to go about the line, x equals 6. Okay, x equals 6, like we said before, is a vertical axis right here. So we're going around this axis right here, so it's going to look kind of like if I create a mirror image, just so we can visualize. As I scoop around, as we scoop around. Okay, so I've got this shape here as we scoop around our vertical axis, x equals positive 6. Okay, so when we're going around a vertical axis, we're thinking of the shell method. Okay, and the shell method is based on a to b, 2 pi r. This is the circumference as we sweep around in a circle, times our height. That's going to be the difference between the two functions, and the thickness, the tiny little thickness of each circle as we scoop all the way around. Okay, so we're going to set this up. So we need to calculate out the radius. We need to think about the height. So the radius on our shell method, in this case, is going to be my axis minus my particular radius. Where am I at? Right, so I'm going around here, x equals 6. Normally, right, if we're going around the y-axis, this is our y-axis here, I think about my radius. How far out into this function am I, right? I just go x. How far out am I going? And I'm just going around. That forms my radius on the shell method. But now I'm going around this axis right here. Okay, so I have to think about the difference between my axis, which is 6, and the radius. Where am I actually at as I move my way through A to B, okay, from 0 to 4. Okay, so x tells us how far out we are as we go from 0 to 4. And then this, right, is going to tell us the differential between these 2 points here. So my radius in this spot is 6 minus x. Okay? And now the height, okay, is basically going to be our upper function minus our lower function. Okay, so our upper minus our lower, which I can write out as minus x squared plus 3x plus 4 minus x plus 4, which if I distribute the negative gives me plus x minus 4. So my total height function is going to end up looking like minus x squared plus, sorry, not 3x plus 4x. Okay, 3x plus 1x is 4x, the 4's cancel out. Okay, so that gives you my height. So taking the height and the radius, I'm going to plug them into here. Okay. So our volume is going to equal, we're going to go from 0 to 4 to pi times our radius, 6 minus x times our height, minus x squared plus 4x times the tiny little thickness of each circle as we sweep our way through. And that was it. They didn't ask us to actually evaluate it. They just asked us to set up the integral. If we wanted to evaluate it, we could distribute these. Here we basically just integrate based on the power law, but we weren't asked to do that. Okay, so that was final exam fall 2018, question 7.